Professor Lobster. There's a wise old man from the bottom of the sea. He's come to help both you and me. How things work and how things go. Anything you want to know. So if you don't know, I want to know. If you don't know, I need to know. If you don't know, I've got to know. Just ask. Professor Lobster, build a house for me. Somewhere I can go to watch my TV. Professor Lobster, show me something new. Maybe when I'm older, I'll know as much as Professor Lobster.
This is the Professor Lobster show, and it's all about
concrete.
What are you doing on the television, Professor? Come out. What are you doing with that spider? I hate
Now, what do you really hate the most? What really frightens you? Is it spiders? Well, this is a red-legged tarantula from Mexico. He's not that bad, really. He's a hairy creature, climbs around people. Especially when you talk to him nicely.
Professor, come out and let's get on with the concrete. The show's already started.
That was a bit hairy with the spider. Let's see what's in the cupboard.
What are you doing?
Monty? Monty? Well, let's see what's in there. Now, with a name like Monty, it's obviously got to be an Indian python. Now, isn't that beautiful? Now, you may wonder why I've got a python when I'm on a programme talking about architecture and building materials, but it makes me want to ask you a question. Why do you hate snakes?
Because they're horrible.
No, they're not. Look how beautiful the shape are and the patterns on it. It really is lovely.
Because they're poisonous.
No, this one isn't. Some are, but this one isn't.
Because they bite.
Well, this one doesn't. They only bite you if they're hungry or if they're frightened. But what it is, people actually think that they're evil. Now, why is that?
From the Bible.
That's true. Now, do you remember, in the Garden of Eden, the serpent was the devil, and he was there in a tree, and he tempted Eve to take a bite of the apple. Well, serpents aren't really very interested in apples. That's not bad. Well, I think the snake got a very bad deal out of that. It's a shame.
What's he got to do with the show, though?
What's he got to do with anything?
Now, that's a very good question. Because the important thing is I don't want you to be prejudiced about snakes, because it's quite lovely. And I don't want you to be prejudiced about concrete, because it's a very interesting material when it's used properly. Now, look at that.
It's just a piece of concrete.
Yes, I know, but it's a good building material. It's very useful in lots of ways, and what we're going to do is see how it's made. And what they do is they use it in buildings for floors, beams, columns, foundations, drains. We build bridges with it, motorways. The modern world would be very different if we didn't have concrete. Now, sometimes it can be a fun material.
We'll see about that.
Now, let's have a look at the menu for this week. We've got, first and most important, the mix. Concrete's just like making cakes. If you get the ingredients right, it's terrific. If you get them wrong, it can be disastrous. But it's very strong, that's the second thing, strength. Remember, it's like rebuilt stone, so it's very strong in compression. You can press it down. But like stone, it's weak in tension. But there is a good story. You can reinforce it with steel, just like the skeleton inside this snake. You don't see the skeleton, but it's there. And it's the same with reinforced concrete. The steel's inside. And there's lots of different uses for concrete, and also there's some very good finishes.
You said concrete can be fun. I want you to prove it to all of us.
Very well. Well, I need an egg.
An egg?
Yes, that's right. Thank you. Now, we're going to go and see someone that lives in a concrete house.
But what's the egg for?
Wait and see. The inspiration for this building was an egg, which is one of the most perfect forms that nature makes. Did you know that? And did you know this building was designed for penguins so they could walk up and down the ramp? And you are living in one of the best examples of reinforced concrete that there is in the history of British architecture. It was designed 52 years ago, and it's a really good example of its kind. I hope you like it.
Did you know, Prof, that this was designed by a Russian architect called Lebedkin in 1934, and he's actually 4 years older than you?
Yes, and it's still in good condition. These ramps are 14 metres long, and they go all the way around without any columns underneath, and they're curved in 2 directions.
Yeah, but it is a bit wobbly.
Well, yes, but it's been calculated that it'd carry about 330 penguins. Now, what did you think of that?
Well, Well, there was no water in it, but as long as the penguins liked it, that's all that matters.
Hey, now just you behave.
Water.
Penguins are supposed to be
Water.
cute. There's going to be a lot of water in that penguin pool eventually, and we need water to make concrete. Right, and we also need some ingredients. We need cement. Oh, there we are. That's the one that binds everything together. It sticks the other things together. The second one is sand. Now remember, sand is small stones. And if you're making a lot of big concrete for a building, you use stones, that's aggregate. But what we're going to do is make some with some cement and some sand and some water. And what we're going to do, missed. What we're going to do is measure the quantities out very, very carefully. Now, we've got the mix here. Remember, it's like making cakes. 0.25 of a kilogram of cement, 1.25 kilograms of sand, that's a proportion of 1:5, and then 0.25 kilograms of water. Don't do it at home in one of these, or it'll be a disaster. What we're doing now, you put the ingredients together first, and you add the water to them. It's very important to do it in that order. Switch it on and get it mixed up first. You've got to mix them together evenly, otherwise the concrete will be uneven in quality. Oh, it's struggling with this. That's why we've not put these stones in. It's a chemical process. The water makes the cement react, and it's cementing them together and making it very, very strong. I think that's enough. Yeah. Turn it off. Let's have a look. So feel that. Ah, it's not a bad dry mix. There we are, see? Fairly, it's okay, that. Right, are you ready, helpers? This is going to test you. We've got 2 volunteers from each of the 3 teams, and over here we've got a concrete production unit. So come on, let's see what you can do. Now remember, you've got to mix them in the right quantities. Measure them carefully and put the cement and sand in first, followed by the water. Come on, let's get on with it quickly. Quick as you can. Now, the other thing, while they're mixing that, come on, speed. Time's money in the building business, same in television. But what I've got here is the other half of the story. It's all very well making concrete, but you've got to do something with it. You've got to pour it into something in order to make the shapes you want. You pour it into a mould. Shuttering, architects call it. And imagine these are 2 people walking up to a beam. There we are, walking towards a very big beam for a motorway bridge or something like that. And what this is made out of is wood. It's made by carpenters, and it's got sides and ends, and it's got support so the whole of the formwork stays together, and it's got wedges so that it stays tight, and also so it can all be knocked to pieces at the end and taken off when they've poured the concrete into it. Now, when they've made some concrete, we're going to pour it in this, and if you've got the ingredients right, it'll just fill it to the top. Now, we're obviously not very good at this, but we are learning. In fact, when you have to be a builder, it takes you a while to learn how to build. Same with being an architect or an engineer. You can't do it straight away. In fact, I think we're only getting about 2 out of 10 for making this concrete beam. But what we've done is we made some concrete beams the other day, which we're going to test. This looks just like a factory making big concrete beams, sort of mass production. This is what builders like, makes them cheap. But what you've got to do is take the shuttering off the beams, and it's all wedged, and you lift the concrete beam out there. You can reuse the shuttering sometime, and what we're going to do now is test this concrete beam. Now, do you remember we tested a stone beam in the first programme, and we're going to do the same sort of thing now. So we've got 1 kilogram in the centre of it, and put another 5 on. This is going to make it 6 kilograms, and 5 makes 11. You see, concrete gets stronger. The longer it's there, the stronger it gets. And when we've been making these, depending on how many days they've been made, they get stronger. This is surprising. It's a bit stronger than we expected. Oh, no, it's not that strong, really. That just failed very, very dramatically. In tension. It broke at the bottom. Now, how could we make it stronger?
With steel.
That's right. Now, there's some steel in this beam here. What we've got is a concrete beam. It's reinforced with steel, and it's spanning between my hands. And what we're going to do now is go to the longest span in a building in Europe. 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44,
I don't know why he's brought me here.
48, 49, 50,
All he's doing is proving he can
52,
walk and
53,
can.
54, 55, 56, 57 metres.
What is?
This garage, it's 57 metres, clear span. It's the biggest concrete structure of its kind in Europe.
Oh, I see, it's concrete. But you're going potty doing that?
I think it's a really good example of this kind of building. It's very strong and it's big enough to hold 200 London buses. It's the Stockwell bus garage for London transport. Now, when it was built 30 years ago, it was a very unusual building, and I don't think they'd build any more of this kind of building.
Why couldn't they build it again then, Prof?
Well, they could build it like this if they wanted to, but when they built this, they were very short of steel. Now, steel isn't as expensive, and there's plenty of it about, so they build a span this big in steel, probably. But what I like about it is it's like 9 bridges next to one another, big arches, with vaults between.
Why did they build it in an arch? Why don't they build it straight?
Well, it's stronger in an arch. If they built it straight, the weight of the concrete itself would tend to make it all sag. But because it's got arches and vaults, it's a bit like a cathedral roof, only wider. This is like a Wells cathedral, but built for buses. One of the biggest problems with reinforced concrete is getting enough concrete to cover the steel reinforcement. If it's too near the surface, the water gets into the concrete and it makes it rust. Look at this bar here. I can get my hand right behind it, and it'll be pushing the concrete away. Now, what they've done is they've cut the concrete away around this, and the good news is it can be repaired. There are special resins and concretes that can be applied to problems like that, and finally they finish it with a good coat of waterproof paint. Do you realise, Liz, it's like we're sitting on an eggshell?
We're not.
Well, we are in proportion. This concrete shell is only 75 millimetres or 3 inches thick.
We could fall through it.
No, we won't. It's reinforced concrete. It's got steel reinforcement and it's curved in 2 directions. And that makes it very, very strong. It's also a very wide span, remember? 57 metres clear span. And we are sitting here and we're a little bit like two fleas on the backside of an elephant.
Oi, Prof, this is just a load of old rubbish.
Well, it's very interesting to me. It's the bad news about concrete, though, because what it shows is where the concrete had failed. The concrete hadn't got behind the reinforcing because it was too near the shuttering, and this building collapsed, and sadly some people were killed. But concrete usually can be a good, strong structural material, and here it is. This is a reinforced concrete column. You can see the steel reinforcing bars are in there in the middle, and they're well covered by a good thickness of concrete round the outside. A good, strong structure. This is another good, strong structure as well. What we've got here is a concrete drain pipe, and this has got reinforcing inside, and what I'm doing now is looking down the wire cage that makes the reinforcing for this drain. It's a very strong structural form. Now, I think we should go and test our beams that we reinforced. Now we've got a small concrete beam here that's been reinforced with 2 small steel rods. Now, put it in our test bench. It's the same size as the other beam. Do you think this will carry more weight? Yes! Well, what did the other one fail? About 15, didn't it?
Yeah.
So we've got 1 and 5 more. 6. We'll have another 5.
11.
If it's reinforced, well, let's see what'll... Put these more on, that's another 2. Oh, nah! Oh, shock horror. Now, that's failed on 13 kilograms. Now, that was less than the other one, and yet it's reinforced. Now, do you know why that happened, Liz?
Yeah, because the rods are at the top, they should be at the bottom.
She's right, you know. If we turn it round the other way with the rods at the bottom, it should take more weight. 11. No sweat. Quite easy, this. 16. No problem. What are you standing back for?
20.
It's reinforced at the bottom, see, it still hasn't gone. That's twice as much nearly. 26 is still there. Any advance on 26? 30. Look at it. Come on, let's have 10 more. Now, this is really something. We're all licking our lips.
41.
It isn't there yet. Just putting this on very gently. Now, look at that. 2 little bits of steel have made all the difference. And another 4, and it's still holding. And the last 2 we've got, and I'm disappearing behind it. Now, that's pretty strong with 2 little bits of steel. Thank you very much. Whew. Well, that's enough testing of beams for the time being. I now want to go and look at some very long, slender columns. This is the old Coventry Cathedral. It was bombed during the war, but they built a new one in the 1960s. It was a very modern design. It uses materials in very interesting ways. Well, the good thing about concrete is it can be poured into moulds into interesting shapes. And oh...
Professor.
Yes?
This is just your sort of building, isn't it?
What do you mean by that?
Well, when a building loses its roof, well...
What's this, Elizabeth?
Well, it could be a shin pad, but I think it's an angel's kneecap.
And what's it made of?
Well, it's acid-etched glass and it's been cut in. I think it's wonderful.
I think it is too. I love the way the light comes through it. Looks like ice, Jack Frost.
Professor.
Yes?
I think this concrete's really smooth.
Yes, it is, and the corners are very good as well.
Why is it so smooth?
Well, because it was done in a smooth shutter, and it was probably steel, and then the steel had oil put on it, so the concrete wouldn't stick to it. It's a lovely finish.
Lucky your head gets under that bronze shoe, Professor.
You know, this bronze shoe was almost a glass slipper. I'm serious, and I'll bet you don't believe me, but the architect for the cathedral, Sir Basil Spence, when he was designing it originally, wanted to have these columns held up on solid bowls of glass.
Well, why didn't Sir Basil get his way?
Well, they'd never done it before, and I suppose it would have been a bit difficult to do it in a cathedral.
It's a good job it's bronze, not brass.
Why?
Because bronze is stronger.
That's true.
One important thing about Coventry Cathedral is the different ways in which concrete is used, in the windows, for instance. The precast concrete columns hold up a decorative wooden ceiling, and above that is a thin concrete roof which spans from the walls on either side. Now, this concrete penguin is made out of cement, sand and water. Oh, I fell for that again. I thought you'd had that disconnected. Anyway, we're going to make a zoo. Here are some animals. If you've got a wooden frame, you could make these in school, and they've got chicken wire around the outside for reinforcing, and there's paper stuffed in the middle so it'll stop the concrete falling inside. And we've mixed some concrete here. Just going to pour it into that barrel. There we go. You have to keep it turning to make it come out. I'm going to deliver this over to the penguin. So we've got an elephant, a giraffe and a penguin, and you're all ready to go. Remember, it's not a competition. I've tipped more in there than I expected, and we won't need this much for the penguin. But what you can do is stick it on and have fun. So it's like sculpture. You see, concrete can be artistic. So have a go. Show is the best of the series.
Yeah, but sadly it's the last.
Well, that's a shame, but we've enjoyed ourselves, and we'll enjoy ourselves next week, because it's going to include dressmaking, and it also has lots of those buildings that we all like best, and I'm talking about tents, and we've got Professor Lobster's big top. So, remember, there's the Professor Lobster salute, and the motto, if you don't know, ask.
Professor Lobster.